Hello and welcome to this video. In this video, we'll be talking about context engineering. In the previous video, I showed a demo of how to run large language models on your local machine. If you run that demo application, you would have noticed that the LLM doesn't continue the conversation. Let me show you what I mean. So here's the application. I'm going to send a prompt and then I'm going to try to send a follow-up. So here's the prompt. It's generating a response. Great. So now I'm going to try to send a follow-up. Exactly. So it says, without additional context, it's difficult to determine whether something is big, right? It has no idea of what the previous conversation was. And this demonstrates how LLMs function under the hood. They are stateless. They don't persist record of previous conversations. They don't persist responses. They treat every prompt like a fresh start. So if we wanted, if I wanted the LLM to continue this conversation and keep generating responses about China, which was the question I asked, I would have to pass along with subsequent prompts the record of previous conversations. I'll have to send that along with subsequent prompts as context to the LLM, because LLM, basically whatever you send as context is what the model uses to generate responses. And so this brings us to what we'll be talking about today in this video, which is context engineering. So context engineering is the process of designing, organizing, and optimizing the information we feed to an LLM so that it can fit within the model's token limit. Now, every large language model has a limit to the context, the length of the context that it can process at once. There's a limit for every large language model. As of 2025, we don't have models that have unlimited context window. All the models we have right now have a fixed context window. So that creates a limitation in a way, because now we can't just lump all the record of all our previous conversations and just send it to the LLM. No, we have to be smart in the way we design the context, in the way we design the information that we are sending to the LLM. So in context engineering, we are optimizing for information relevance. So you're optimizing you're trying to get the right piece of information. You don't just want to send junk, things that are not related to what the LLM needs to generate a response. You want to send the right piece of information. We optimize for the token limit, because you don't want to send information that would exceed the size of the context window, which is the token limit. And also we optimize for cost. Now, if you use external inference APIs, like the one from OpenAI or Anthropic Claude, they charge based on the tokens. Your context is converted to tokens and is fed to the LLM. So they charge based on tokens, and the tokens, the input tokens and the output tokens from the LLM. So in context engineering, we optimize for cost. So you're not you're not wasting tokens, basically. So yeah, let's look at the core components of context engineering. Now, in context engineering, we have RAG, we have a component called RAG. RAG is a technique that we use when we are dealing with information from factual sources. So you're dealing with information in documents, in the knowledge bases, FAQs on the website, or maybe even from a remote API. We use RAG approach to get that piece of information to our context. The next component is prompt engineering. Prompt engineering is how we define the instructions that we send to the model, and how we define how it should generate our responses. The next is state and history. So state and history, this is how we manage the conversation history, right? How we save conversation history so we can have a record to pass along to the context and send to the LLM. And the next component is memory. Memory is long-term information or data that persists across sections. So things like your name, maybe your occupation, just things that you want to persist across sections, across new sections. So we can save that as memory. And then the last component is structured output. Structured output, we can provide instructions. This also includes is also included in prompt engineering. We can provide instructions to tell the LLM to generate outputs as maybe JSON object or Markdown. We can tell the LLM to generate output however we want, whatever output structure we want. Right. So these are the components of context engineering. I have used several of these components, not all of them. I've used a few of them to put together a context pipeline to help us fix the issue with the application. The issue I showed in the demo, I've combined a few of those components to create a context pipeline that handles that issue. Let me show you the code, and then I'll show you the context pipeline in action. All right, so here's the code. I created a use context pipeline store, and I'm using Zostan. So you can see in the app state, I have conversation history, which is an array to keep a record of the tones of the conversation. And then I have conversation summary. This is supposed to be for memory, but I'm not handling memory. And this is supposed to be for RAG, but I'm not handling RAG as well. So I'm just handling conversation history and conversation summary. So the idea behind conversation summary is for conversation history, we keep a record of all the conversations. But then when we want to send subsequent context to the LLM, I take like the most recent. So there's this idea of sliding window. So I take the most recent, 3 of the most recent tones, and then the older conversation records, I summarize them basically. So here's the code that does that. So you have if the length, the conversation history length is greater than 6. So the reason 6 is each tone is 2 items. So we have the user prompt and then the LLM's response. So that's 2 items. So a sliding window of 3 of the most recent conversation will be 6. So that's basically the thinking behind this. And then I have the summary of older messages, just summarize them and save them in the store. So this is it. Let me show you how the prompt looks. So here's the prompt. Here's a function that I have to prepare the prompt. So in here, conversation summary, we have the label, and then we'll pass in the conversation summary. First, we get the information, we get the records from the store, and then the label and the summary, recent conversation, and the tones. If I add memory, this is how the memory is added to the context. retrieve document. If I add RAG, this is how it also is added. And then here's the prompt. So you can see the prompt, I have guidelines just instructing the LLM on how to generate the response. So if I wanted the response to be in JSON, I could also define it here, and the LLM would return the response in JSON. So this is the prompting, how the prompting is done. So let me show you the pipeline in action. All right, so here's the application. Let me send in a prompt. Okay, so the same prompt I used in the initial demo. All right, now I'm going to ask a follow-up. And yeah, so now it has an idea of the previous response. It has an idea. The LLM now know that I'm talking about China, so it's able to give me, the response that I want. So yeah, that's the video on context engineering, and thank you for watching. Do like and subscribe to the channel, and I'll see you in the next video.